All right. So since that you are ready, we are going to talk about the superficial understanding the patterns of the periodic table. And of course, before we understand the patterns in the periodic table, we must be able to know the basic unit, which is all about the atoms. But first and foremost, let's just have a prayer. Thank you, Lord, for giving us this day. Thank you for keeping us safe and our family. May you guide us and help us to learn in a meaningful virtual experience in science. In Jesus' name we pray. Amen. Alright, and of course, today, as you can see, this picture talks about how Mendeleev created the first modern periodic table, where Mendeleev was the first one who put everything in place. Okay, those elements in a table. So, as you can see here, there's a question: what does it show, and why is it always in the same order? Basically, he just observed all these elements and placed it with the same characteristics and properties. Okay, so that's how he did it. All right, so that was the start of organizing elements in a periodic table. Of course, at first it was just very simple table. So as time goes by, other scientists wanted to make it in a periodic way. So pag sinabi natin periodic way, meron siyang pattern, which these elements share the same properties and characteristics, and as time goes by, change in number, change in size, and change in reactivity. Okay? Because that's how atoms behave. Alright. And of course, this is the example of periodic table. And we have here an element or an atom of hydrogen. Okay, so periodic table is simply the compilation of all the elements that can be found whether in nature and whether artificially made. So an atom is equivalent to an element. Remember that an element has atomic number, atomic mass, atomic name, and symbol. So ito yung mga makikita natin. These are the things that we can observe in the periodic table. It has atomic number, atomic mass, and atomic name and symbol found in the periodic table of elements. So when we talk about elements, it's not about fire, wind, water, and ground or earth, but these are all the elements that, of course, where we can find the compilations of different atoms as well. All right? And there are 92 naturally occurring elements. When we say naturally occurring, this can be found, of course, on the Earth's surface itself. It can be found in nature. All right? And about 24 artificially produced elements. So when we talk about artificially produced, these are man-made or synthetic elements. It was done or created inside the laboratory. Okay, so light elements. Let's just have a short background. Light elements, when we talk about light elements, these are not heavy elements. In Tagalog, magagaan. Okay, light elements such as hydrogen and helium are formed from stars. That is why stars and the biggest star that we have here, which is the sun, is made up of hydrogen and helium. Okay, so lahat ng bituin, all the stars are made up of hydrogen and helium. They are formed stars or they form from stars and they also form stars. Alright? So they fuse together to make heavier elements such as carbon. So by fusing together, that is nuclear fusion, they can make heavy elements. So from hydrogen and helium, when they fuse together, heavier or heavy elements produce. Alright? And of course, there are some even heavier elements that were produced deep within the stars. Okay, so as time goes by, it started from hydrogen to helium. When they combine together because of nuclear fusion, it becomes heavier and heavier and heavier and heavier until such time the production of other elements. All right, and of course, most of the artificially produced elements have only been made in nuclear reactors or particle accelerators. So these are the equipment that is being used for them to produce, okay, artificially made elements. Am I clear? Just a reminder, class, do not forget to turn off your microphone. Wala mo nang nag-on ng mic so that there will be no unnecessary noises. Alright? And of course, each element is made up of one type of atom. So again, one atom is equivalent to an element. So when we talk about the atom of hydrogen, that is the element of hydrogen. One element is equivalent to one atom, which is different to the atom in any other element. Sometimes we use color. Okay, we use color for us to be able to distinguish one atom to another. So we have gold. Okay, that's the first example that we have. Gold is an element made up of only gold atoms. If it is pure gold, am I clear? But if the jewelry that you have, of course, it is mixed with other metal, it's not pure gold anymore. Alright? Because that is an alloy. If that's the case. Then we have carbon. In Tagalog, uling. Okay? Yung charcoal, that's made up of pure carbon. Or yung putik. Okay, carbon is made up of carbon atoms, which is, we know, charcoal. Alright, then we have oxygen. In the oxygen tank, it is made up of, inside of it are oxygen atoms. So they are all made up of atoms. Alright, so there are a lot of things that can be found at home, like aluminum. Right here, familiar with aluminum, right? We have copper, can be found in wirings. Alright, and a lot of elements that can be found at home and even outside your houses. A lot of, because everywhere you can find them. Whether you are inside your bathroom, inside your bedroom, whether you travel anywhere, you can find elements in everything. Alright? And of course, I just want you to look at this diamond. Diamond is also made up of carbon atoms. Same as with charcoal, same as with the graphite that inside of pencil. Alright? So diamond is made up of carbon. The same element as the graphite in pencils, like what I've said a while ago. And we know that carbon atoms is very important when it comes to living organisms, because without carbon, we cannot consider that living organisms. Alright? That is why we have what we call organic chemistry and inorganic chemistry. When we talk about organic, as you remember, we talk about substances or objects that has carbon atoms. On the other hand, inorganic atoms, not totally without carbon, but only some of them, all right, has carbon atoms, such as this one, which is carbon. All right, carbon in diamond. Diamond is not living organisms or organism, but it doesn't have any what? Any other element except for carbon. So, diamond is considered as under inorganic, all right, substance or object. That's how we differentiate organic from inorganic. Organic with carbon atoms, inorganic without or some carbon atoms. All right, so since we know that diamond is made up of carbon atoms, there is what we call lattice. So lattice is look like this one. As you can see, it is a symmetrical structure that shows the different bondings in carbon. Okay, it's a 3D model that shows, oh, that's how diamond looks like crystal. Okay, and of course, some crystals such as sodium chloride, which is our table salt, all of the solids that has a crystalline structure, it has a lattice like this. It shows a 3D symmetrical atom bonding. Alright, that's why they look like very edgy and it has different sides as well. All right. And based on what we have learned, every element has a unique atomic number, right? And that atomic number signifies their reactivity and at the same time their sizes. Later on, you will know that as we go on to our topic. So this is the number of protons in the nucleus of each atom. Remember that each atom has its own number of protons and number of electrons. All right? And that is also related to their atomic number. So when we talk about atomic number, example, we have one hydrogen. Okay? Hydrogen is number one in the atomic number. So it has one proton. Am I clear? So if that's the case, in a neutral atom, if hydrogen has one atomic number, it has one proton, it has also one electron. Okay? And now, what is the atomic number of this helium atom? Since hydrogen is 1, therefore helium is 2. So the atomic number of helium is 2. So the proton is 2 as well, the neutron is 2 as well, and the electron is 2 as well. So this is a neutral helium atom. When we say neutral, this is the common one. Okay, because all of the elements that can be found in the periodic table are neutral, meaning to say that is their real state. Alright? There's no change at all, but that is their real state. Okay, so that is the neutral atom. So if helium has atomic number of 2, remember it has 2 protons, it has 2 electrons, and 2 neutrons. Alright. Am I clear? And atoms are neutrally charged. This is what I told you a while ago. So what links atomic number and the atomic number of electrons? Atomic number is the same as the number of proton and the number of electrons in a neutral atom. Okay, there you go. A neutral atom must have equal numbers of protons and electrons. So the atomic number of an element also gives the number of electrons. Remind you, class, only in neutral atom, because there will come a time that the atom will not be neutral anymore. Right? So an atom is made up of subparticles, namely electrons, protons, and neutrons. Remember that electrons are negatively charged, which is the smallest particles moving around the nucleus. And protons are the positively charged particles found in the nucleus, which is composed of its entire mass. Alright? And neutrons as well, these are the neutral or the no charge particles of an atom found in the nucleus as well, together with the protons. So these are the subparticles that plays a very important role on their discovery on the model that we have last time. So if you are familiar with these subparticles, you will all know that this is the structure of an atom. And this model is the planetary model. Alright? That those moving smallest particles are the electrons, while protons and neutrons are located at the nucleus of the atom, which compose of its mass or weight, of course. And electrons can be transferred while protons and neutrons are very heavy, which will lead us to their atomic weight. Like what we have said in our periodic table. In the periodic table, you can see there the atomic number, atomic element, the element name, and then we have the symbol, and of course their atomic weight. So it can change its weight, class. Alright, that's why sometimes atoms cannot be neutral anymore because there is change in weight. Okay, later on we will tackle about that. And to proceed, in chemical reaction, remember this, the nucleus of atoms are neutral, while not in nuclear reaction. So in chemical reactions, of course, all of the atoms that undergone chemical reactions are neutral. But in nuclear reaction, it is not neutral anymore because there's change in weight, there's change in atom as well. So atoms can lose or gain electrons in the process. Do not forget that since electrons are the moving part, they tend to transfer from one to another. That's why an atom can gain or lose electrons. Okay, you will know how these electrons behave from time to time. Okay, and this is what the structure of one cube of an element in the periodic table. You can see there the atomic mass, you can see there the elemental symbol, and you can see there the atomic number. And also some of the cube in the element or periodic table of elements has their name. Okay, so the normal or neutral atom has the same atomic number with protons and electrons. The mass number is equal to the total number of protons and neutrons, like this one. Mass number minus atomic number, you can get the number of neutrons. Alright, so get the mass number or the atomic mass minus atomic number, you will get the number of neutrons. Okay, vice versa, in getting the mass number is equal to the total number of protons and neutrons. So when you add up neutrons and protons, you will get their mass number, of course. Since atoms has no fraction of neutron, round it off to the nearest whole number. So if it is 4.003, round it to the nearest whole number, which is 4. Okay? Then protons and neutrons are made up of smallest particles called quarks. So now let's go to the charges of atoms. So different subparticles has different charges. But first, I want you to remember the word ion. Ion is when electrons lose or gain electrons. Okay? So it can be an atom can lose or gain electrons. This now the term that is going to use ion. Okay? An atom that gain electron become an ion, and an atom that loses electrons become an ion. Okay, of course, in ion there are two categories. A monoatomic and positive ion is called cation when atom loses its electrons. Nakaintindihan? Meaning to say, when atom loses its electrons, it becomes positively charged because it loses electrons. Okay, you subtract electrons from it. Am I clear? While on the other hand, a polyatomic and negative ion is called anion, which means atoms gains electrons. When an atom gain electrons, you add negativity, right? So it become an ion. When an atom loses electrons, you release negativity, you become positive, so the atom become cation. Alright. So for example, this one, a neutral atom, when you lose electrons, it become cation. When neutral atom gain electrons, it become negative ion, which is called an ion. Alright? Ions became different in its chemical properties. When we say monoatomic, sometimes cation or of every time, of course. Monoatomic, which means one. So cation is basically composed of one atom. That's why monoatomic. On the other hand, polyatomic, which is an ion, sometimes it is combined with other atoms. Am I clear? Alright, so those are an ion. Example, hydroxide, that is OH. Alright, we have oxygen and hydrogen at the same time in an ion. And there are a lot of anions that later on you will encounter. Okay, so those are the negative ions. So remember, charges that are the same repel, charges that are different attracts. So that's why there's an attraction here that will happen sooner or later. So example like this one, we have sodium, which is a cation, and we have here the chlorine gas, which is an anion. So you will remain the name of the sodium since it's positive cation. Then chlorine gas will change its name to an anion, to chloride. So when sodium and chlorine gas combine together, you will form sodium chloride. Alright? So sodium positive, chlorine gas is negative. So when they combine together, since they are with different charges, they will attract, right? And another one, potassium fluoride. So we have potassium, which is cation, and then we have fluorine, which is an ion. When they combine together, of course, it will form another substance, which is potassium fluoride. So that's how potassium fluoride came into the picture. It's because of their cation and anion. Alright? Again, it is because of the gaining and losing of electrons. That's how ion produce. Alright. Now let's go to isotopes. Isotopes are the same elements but with different number of neutrons, identified by their atomic mass number. So isotopes can be this one. Okay, this is an example of isotopes. These are isotopes of hydrogen. Hydrogen 1, hydrogen 2, and hydrogen 3. The same element but with different number of neutrons. You can identify them by their atomic mass number. So all of these are hydrogen, but they differ in their atomic mass number or atomic weight. So hydrogen 1 has mass number of 1, hydrogen 2 has mass number of 2, which is what we call deuterium, and hydrogen 3 is composed of mass number of 3, which is what we call tritium. So as you can see, there's no presence of neutron here, and over here there's an additional neutron. That's how it has a mass number of 2. It becomes heavier, of course. So that's a different hydrogen from hydrogen 1. That's why it is called deuterium. And another add up of neutron here. So it becomes heavier again, right? So it becomes hydrogen 3, which is known as the tritium. And those are what we call isotopes. Remember, isotope notation is used to convey the information to see the example. Okay, I want you to look at this example. There you go. Protium is hydrogen 1. So this is their atomic number at the bottom, and the isotope will appear as the superscript on the top of it. Hydrogen 1, hydrogen 2, and hydrogen 3. That is different from one to another. Again, the same element, but different number of neutrons or mass number. Of course, that's an isotope. While ions, again, ions are atoms that's either gaining or losing its electrons. All right? Now, let's have a diagrammatic representation of an atom. An atom has different energy levels. Each energy levels or shells contains electrons in quantum mechanics. So these energy levels or shells plays a very important role when it comes to chemical reaction. All right? And of course, these energy levels or shells consist of subshells. Kumbaga, meron silang main shells or energy levels, and these energy levels has subshells as well. And these subshells assumes to have one or more orbitals. Orbitals is where electrons occupy. You can imagine as this way. There is a building, of course, a rental building where you can rent an apartment or rent a room. All right. So in each, of course, that building has different levels, right? Or different floor. Imagine that. First floor, second floor, third floor, fourth floor. Those are energy levels. All the subshells, of course, are the different floor as well. Okay, example. First floor A, first floor B. Those are the subshells. Okay? And of course, those different floor has its different room. And those room are the orbitals. Okay? Of course, the people are the electrons who will rent that room or in that apartment. And something like that. I just want you to imagine that at that way. So like this one. So this is the diagrammatic representation of atom with energy level. So this is the nucleus of the atom. The nearest, of course, is the first energy level. Then the second one is the second energy level. The third is the third energy level. And the last, of course, the outer part has the fourth energy level. Am I clear? This is how they look like in a diagram. And like what I've said a while ago, imagine a building with different levels or floors with different rooms. In each room has one or two tenants. Okay? Yung energy levels and yung mga floors. Okay? And in that floor, there are, of course, different levels. Like this is floor A and floor B in the first floor. In the second floor, this is floor A and floor B as well. And in each floor, in each corridor there in the apartment or building, it has different rooms, right? For example, you are the caretaker. Okay, this room can only occupy 2 tenants. This room can only occupy 10 tenants, something like that. All right? And this is how electrons arrange in shells. So electrons are arranged in shells around the atom's nucleus. The shells can also be called as energy levels, like what I've said a while ago. So this is the nucleus, first energy level, second energy level, third energy level. So you can see in the first energy level, you can only occupy 2 electrons. In the second energy level, you can occupy 8 electrons. And in the third energy level, you can also occupy 8 electrons. That is the maximum class. Alright? And each shell has a maximum number of electrons that it can hold. Electrons will fill the shell nearest the nucleus first. Like in the apartment, if you are the landowner or if you are the caretaker of the apartment, of course, your rule, right? And your rule is for you to fill out the first floor of the apartment. Same as with this one. You will first fill out or fill up the first energy level before you jump off to the second energy level. Alright? So since electrons are moving, so the only subparticle that you can move are electrons. Am I clear? So in the first energy level, only two electrons can fill it out. Am I clear? In the second energy level, you can fill it out with a maximum of 8 electrons. Alright? And like in the first shell holds a maximum of 2 electrons. This is what I said a while ago. And the second shell holds a maximum of 8 electrons. And the third shell holds a maximum of 8 electrons again. So that is the maximum, meaning to say there's a minimum. It can be 1 in the first, in the second, and in the third. Alright? So the electron arrangement is written as 288. Alright? And the outer electrons are called valence electrons. Is that clear? The outer part of electrons or the outer electrons are called valence electrons. Those are very important. Alright? And elements in period 2 all have a complete first shell. How is that possible? Okay, let us look at this one. So in group 2 or in the second column of our periodic table of elements, they have a complete 2 electrons in their first shell or first energy level, like lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Sorry, it's in the period 2, not in column 2, but in period. Kasi ang column class are the vertical line of the periodic table, which is the group or the family, while here is the period. Alright, so the second shell in period 2 or the horizontal part of the periodic table that compose lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon has complete the maximum of 2 electrons in the first energy levels, like this one. See? 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7. And as you can see, the valence electron, like this one, 1, 2, 3, 4, 5, 6, 7, 8. So the valence electron of lithium is 1 because it belongs to group number 1. The valence electron of beryllium is 2, which is belong to group number 2, and so on. Valence electron of boron, which is 3 because boron is in group 3, and 4 for carbon because it is in group 4, and so on up to 7 because neon as noble gas, like it is located on the farthest right side of your periodic table. So noble gases has maximum 8 electrons, okay, which is included in group 8. All right, so it means that it's already full. Am I clear? So the second shell is completed 1 electron at a time going across the period from left to right. So when you put electrons from one atom to another, it changes its element name. Alright? So from lithium to beryllium to boron to carbon to nitrogen, oxygen, fluorine, and of course the last part is neon. Alright, and what is special about the outer shell of neon? It is very special because it's already full. It's like you are a man, okay, a human being that has a lot of things in life. It means you do not need any more. Unlike lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, they lack something. Remember this, class. Atom has an octet rule. When we talk about octet rule, 8 maximum electrons on its valence electrons is the stable state. It's like when you have 8 valence electrons, that's your stability. It's like when you are very successful businessman, you have car, you have family, you have everything in life. Meaning to say, those noble gases that is located in group 8, they have maximum valence electron of 8. That's why it's octet rule, from the word octet, 8. So that is the goal of each atom, to have an octet rule or to have 8 valence electrons so that they will become stable. That's why Neon is very special on this part. Okay, actually all of the noble gases are now stable because they have the maximum 8 valence electrons, like this one. Okay, let's look at the period 3. Okay, so the period 3 have complete the first and second shells. Look at this one. Like in sodium, magnesium, aluminum, silicon, we have phosphorus, sulfur, chlorine, and argon. Okay, so what happens to the electrons on the third shell in period 3? This is what it looks like. Since our second energy levels are full already here, so this is what it looks like. See? We have 281, 282, 283, 284, 285, 286, 287, then 288. Again, argon is noble gas, so that's why it has a complete third outer energy level. So the third shell is completed one electron at a time going across the period from from left to right. So the special about argon is that it's completed. It's stable. All right? So that's why it's very important. So to summarize the energy levels, these are the summary of energy levels, subshells, and orbitals. Energy levels or shells, 1 or K, 2 or L, 3 or M, 4 or N. So these are the names of energy levels. The name of energy level 1 is K, then the name of energy level 2 is L. Okay, it's like X and Y, something like that. Then the number of sub levels or subshells are 1, 2, 3, and 4. So the number of sub level or subshell in energy level is 1. Then the number of subshell in energy level 2 is 2. And the number of subshell in number 3 is also number 3 in energy level. And subshell for number 4 is in energy level number 4 as well. Alright? And the designation of sublevels are S in 1, S and P for 2, SPD for 3, SPDF for 4 subshells. So, next meeting, I want you to have your periodic table of elements and we are going to locate these sublevels S, P, D, and F in your periodic table of elements. Is that clear? So that you will understand this number and these letters in your periodic table of elements. And these are the summary of subshell types, number of orbitals, and maximum number of electrons. Let us look at the subshells. Subshell 1, 2, 3, and 4 has the number of orbitals in a subshell. So ito yung mga rooms. Alright? So ang room that can occupy in a subshell 1 is 1. The room for subshell 2 is maximum of 3. The room that can be found in subshell 3 is 5. And the room for subshell 4 is 7. With a maximum number of 2 electrons and 1 on the first orbital, of course, and 6 maximum electrons for the 3 orbitals, and 10 electrons, the maximum, of course, in the 5th orbitals, and 14 electrons, which is the maximum for 7 orbitals. Am I clear? Is that clear, class? Alright, so if that's the case, we can imagine here that in each orbital, there is a maximum of 2 electrons. Okay, so you can fill it out, 2 electrons in each orbital. So for example, if you only have 1, you can fill it out with 2 electrons. If you have 3 orbitals, you can fill it out with maximum of 6 electrons. And if you have 5, of course, you have 10 maximum electrons. And if you have 7, you have 14 maximum of electrons. Okay, so this is the periodic table, right? And the periodic table of elements is very useful for us to be able to know the periods and the groups. So these are the groups. There you go. Groups are the columns. Sometimes it is called as family. So group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. Remember, the group number of the elements here from 1A to 8A is the same number of the valence electron. Okay, so helium down to this element has, of course, the same valence electrons. Fluorine, after this element, has the same 7 valence electron, and so on. While here, the group B, they are all the transition or transitional metals. They are the group B because they shared the same characteristics. Alright, and as well, look at the bottom of it, we have the lanthanide series and the actinide series. Actually, they are located here, but since they are not fit to this part, they just put here at the bottom so that they will have their own identity because they share the same properties. Alright, and in this periodic table of elements, it is color coded. So these are the alkali metals here in the first part. Then we have the alkaline earth metals, basic metal, which is the color violet, halogens, which are the 7A. So when you see this, these are the halogens. Noble gases, so this is at your farthest right, of course. So they are very stable because they have 8 valence electrons in the outer shell level. So these are nonmetals, the orange one. Rare earth, so these are the lanthanides and the actinide series. Then we have the semi-metal or the metalloids in this part. And then the transition metal at the middle of the periodic table of elements. Alright, remember that helium is part of the second A when we talk about energy levels. Alright, so when we are talking about energy levels, let's just put helium over here into A. Is that clear? Because since it's full, we put it over here because it has 2 valence electrons. Okay? And of course, elements arranged by their atomic number and their properties that led to creation of this periodic table that we know nowadays. So this is the modern periodic table. Before, this is not what it looks like. But I just want you to give an overview of how periodic table of elements is very important in our topic. So in this periodic table symbols, they are replaced by atomic numbers. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. Alright, so some of the numbers are missing. Where? Of course, 2 more rows of elements fit over there. That is why we have lanthanide and actinide series. Alright, so the columns of the elements are called groups or families. So we have 1, 2, 8A. Alright, and of course, the rows of the elements called as periods. So we have 7 periods and we have 8 groups. Always remember that we have 8 groups and we have 7 periods. So patterns are metals and non-metals because these are the subcategories of elements. So where are these different types of elements grouped? It can be metal, non-metals, or semi-metals, or what we know as the metalloids. Okay, so metals on the left and the center part of the periodic table, non-metals on the right except hydrogen. Metals, which are semi-metals, which are metalloids between metals and non-metals. Started with boron. Okay, so semi-metals have some properties similar to metals and other properties similar to non-metals. So you can name them as the following. We have boron, silicon, and germanium. Right? We have also arsenic, antimony, and tellurium. Basically, these are used in making circuits because circuits is composed of semiconductors. Right? So they use metalloids, not metals in this part. All right? And of course, these elements are different states grouped together in the periodic table. We have solid, which is on the left, and the center on the right. And we have liquids, which is in the middle and on the right. And gases, that is on the far right, except for hydrogen. Okay? And only two elements are liquids at the room temperature. What are they? We have bromine and mercury, because in a room temperature, bromine and mercury are liquid in room temperature. Mercury is the only liquid metal. Alright? So let's talk about the reactivity of metals. What happens to the reactivity of metals along a period? So along this, from left to right. So the reactivity will look like this one. It increases reactivity from right to left. Alright? So periods is the horizontal part. So when you go from right to left, it increases in reactivity. The more you go to the left, the atom is become reactive. Alright? So what happens to the reactivity of metals down a group? So when you go down to the group, it also increases in reactivity. So, which is the most reactive metal? Fr, or the francium. Alright? And group 0 elements are the most unreactive of all elements. Okay, ito yung mga noble gases because they are already stable. So kapag stable ka na, unreactive ka na. Okay, wala ka nang hahanapin pang iba kasi lahat nasa sayo na. That's why you are very unreactive. Unlike when you are in the first group, you are very reactive because you only have one electron or one valence electron. Remember the octet rule that you have to have 8 valence electron for you to become stable. And since they only have one, they are very reactive. Am I clear? And that one is looking for 7 electrons, of course. So they need to become very reactive so that they can pair to other elements as well. All right? But if you have already 8, you don't have to become reactive anymore. That's why they are called noble gases. So fluorine is less reactive, of course, because it has 7, and oxygen, nitrogen down to down part, then carbon down to germanium, and boron, of course, it become reactive from time to time. Okay, so they are unreactive, of course. And for the remaining non-metals and semi-metals, reactivity increases up to the group and along the period from left to right, like what we have discussed a while ago. All right, and which is the most reactive non-metal or semi-metal? On this part, the most reactive non-metal or semi-metal is boron on this part and fluorine on the non-metal. Okay, that is only for metalloids and non-metals class, ha? So when you look at this part, it increases the reactivity. So the most reactive semi-metal or the metalloid is boron. And in non-metals class, it increases reactivity from left to right. So fluorine down to this element increases reactivity as well. Alright? Am I clear? So, this is the periodic table of SPDF blocks. Remember that we have SPDF room. So these are the orbitals. So when you go to this part of the periodic table of elements, they are belong to S block. When you go to the right side of your periodic table, this is the P block. When you are looking at the middle part, the periodic table, this is the D block. And of course, the last one is the F block. Am I clear? So we have S, P, D, and F. But remind you guys that here, helium is considered as S block. Alright? So you put helium on this side. Am I clear? So helium here is not on the P block but on the S block. So next time, next meeting class, I want you to bring your periodic table of elements and we are going to locate the energy levels, of course, the number of electrons and the orbitals as well in your periodic table of elements. Because on our next topic, we will talk about one of the exciting part, which is the electron configuration. All right? So do you have any question about this class? I do hope that you don't have any questions, but if you do have questions or clarifications, you can chat me in our group chat or you can just PM me if you want to have a clarifications. All right? So if that's the case, I would like to stop the recording so that you will have a copy